In the second example, this is an application of the integration process we've just learned. In part A, we wanted to find a formula for the number of subscribers they have after T months, and this is going to be a general formula. So what we have currently is a rate function, that's m prime. To go from a rate to a general formula requires us to get rid of that prime, and so that we need to do an antidifferentiation process. So for part A, the goal is to find the formula for n of t, given the information that 10,000 subscribers we have is after 16 months. So that means when t is equal to 16, we have a 10,000. So like I said, to find n of t, we're going to use the antidifferentiation process. The integral sign basically cancels out the prime notation. So when we integrate m prime of t, we would get n of t. So if you actually write out the integral, and you see that for the first part of the integral, that's just a power rule, because you're going to add 1 to the power, which gives you the 7/4, and divided by 7/4 is equivalent to multiplying the 4/7. And then for the second part is a constant, so integral of a constant simply becomes that constant times the variable, so 15t. You can simplify that a little bit. 126 times 4/7 gives us 72. And we have everything else that stays the same. And remember that it's really, you get the constant at the end, the plus c. To actually get rid of that constant, that's when we actually need to use what we call the initial conditions. So the initial condition is that when t is equal to 16, you get 10,000. So I'm going to plug in 16 for t in that expression. So you see that everywhere there's a t, I'm going to plug in 16 for it. So we get 72 times 16 raised to the 7/4 power plus 15 times 16, and then plus c. All of that should be equal to the predetermined value of 10,000. So based on this expression, then c is the only unknown here, therefore we can solve for c using regular arithmetic. So simplify the left-hand side, you actually perform the arithmetic. This tells us that 9216 plus 240 plus c is equal to 10,000. Therefore, to solve for c, we're going to subtract 9216 and the 240 from the 10,000 on the right-hand side, which then leaves us 544 for c. Which means that the general expression for n of t should be equal to, going back to the general expression on the end of the second line, you get 72 t raised to the 7/4 plus 15 t plus 544. So that concludes the part A. For part B, it's basically asking you to use the formula you found from part A, but evaluate it at t equals 20. We're looking for n when t is equal to 20. So this is a simple just plug in. So wherever you see a t, you can plug in 20 for it. So we get 72 times quantity 20 raised to the 7/4 plus 15 times 20 and plus 544. Altogether, do this on your calculator, you get 144. 163 subscribers. Remember to put the units at the end of your answer all the time.